Hi and Assalamualaikum warahmatullahi wabarakatuh. I bid to my beloved panels and to all my viewers. My name is Muhammad Haziq bin Muhammad Aliman and welcome to my final year project presentation. The title of my project is Thermal Analysis of Rocket Components. I would like to mention a special thanks to my supervisor, TS Dr. Ahmad Hussein bin Abdul Hamid, and my co-supervisor, Associate Prof. Dr. Zurada binti Saleh, who had helped to guide me through my research on thermal analysis of rocket components. Without further ado, let's enjoy my presentation. Here are the list of the contents which later I will explain each of them in my presentation. First and foremost, let's clear up the problem statement. Due to high operating temperature and pressure, it is likely that the structural strength of the rocket's engine component would deteriorate. This will eventually increase the likelihood of mission failure. Here is an example of failure on launching rocket. As we can observe, the rocket was exploded and burned down at its casing. The failure was caused by the high temperature which affected the structural integrity of the rocket components. Move on to the aim of my research. It is to analyze the transient heat transfer by observing the temperature distribution across the material and components of the rocket, including propellant, inhibitor, nozzle, and outer casing. Besides that, it is investigating the rate of temperature rise within a few seconds of rocket firing. The importance of the study to have a full understanding of the alloy's mechanical characteristics and microstructural evolution under elevated temperatures and strain rates in order to assure the safety and reliability of 60616 structural components under demanding working conditions. For your information, what is the definition of heat transfer? Heat transfer is the flow of heat due to temperature differences and the subsequent temperature distribution and changes. Meanwhile, the transient thermal analysis is the evaluation of how a system responds to fixed and varying boundary conditions over time. In the physical world, heat transfer starts as transient and then reaches a steady state until thermal equilibrium is reached. Next, steady state heat transfer. Characterized by a constant, specific rate of heat transfer. It can be a conduction, convection, or radiation process. We can differentiate the difference between steady state and transient from the boundary conditions used, such as the transient use time but not on steady state heat transfer. Finally, the temperature distribution. It is the rate of change of temperature in a given direction or location. For the first literature review, the researcher underwent theoretical and experimental heat transfer in solid propellant rocket engine. The transient heat flux is determined from the experimental temperature data measured at the outer sidewall of the rocket engine. The study was using mathematical equations such as 1D transient heat conduction equation in cylindrical coordinates to conduct the analysis. For the second literature review, it is the thermal analysis on rocket. The combustion chamber had exceeded 5,000 degrees Fahrenheit, which the structural integrity could be affected due to high temperatures. Hence, the research was done by using MATLAB and ANSYS. Moving on to the scope of work, the rocket was designed with 127mm outer diameter of aluminum 60626 casing with 1 meter length. Next, initial temperature set 26.85 Celsius on all parts with temperature 1326.85 Celsius set on the combustion chamber. Later, the simulation underwent by SolidWorks transient thermal analysis for 2 seconds with 0.1 second increment time, and this is the design of rocket casing. Now I'll explain on the methodology and analysis. The SolidWorks software is first validated for thermal analysis on the rocket components. Then, temperature versus time graph is tabulated under transient thermal analysis. Finally, from the obtained graph, the data will be analyzed by determining the temperature of the interior of the aluminum wall after being heated up by 1326.85 Celsius for 2 seconds. This slide is the section where the simulation was conducted in the SolidWorks transient thermal analysis. First, set the properties to transient type with 2 seconds total time and 0.1 increment time. Then, apply the material for each of the assembled parts, such as for the casing was set to 6061 T6 aluminum. The material properties were already provided in the SolidWorks system. Then, set up the connections at the contact sets. This is vital to provide the heat transfer distributed well among each of the parts. The contact sets were applied bonded for all parts contact surface. After that, for the thermal loads, the initial temperature was set at 300 Kelvin or 26.85 Celsius, which is the same and won't affect the result for all parts of the rocket components. Under the thermal loads, the temperature was set at 1600 Kelvin or 1326.85 Celsius at the combustion chamber along to the nozzle wall. Before obtaining the result, just create the mesh and run the study. After a few seconds, the result will appear on the model. So here is the result of the model by sectional clipping of the part. So easily probe the temperature on the interior surface of the casing. After probing, the graph can be obtained from the simulation automatically. Then the graph data was transferred to Excel to be compiled. The data were obtained at 0.6 seconds as it was observed the temperature was critical at the interior casing. We also can obtain the temperature at a different time until 2 seconds. This result is shown by sectional clipping. It can also show the full model by setting up the section clipping part here. So here is the full model. The second last part of the presentation is the project finding. Based on the table shown, there are 6 locations that probe on the interior of the aluminum casing at 0.6 seconds. It was observed that at 0.6 seconds, the highest temperature reached was 181.8 Celsius. For your information, the melting point of 6061 T6 aluminum is 650 Celsius. Hence, it was worried that the structural integrity of the aluminum could be affected, which may be softening, and defects could occur which may lead to failure on the rocket components, as a softening effect could be the cause as it is induced by high temperature. As we can observe from the legend in the simulation, the highest temperature is 1327 Celsius, but it may be located inside the combustion chamber. Based on the graph plotted, it was from the data tabulated at the probe on 6 locations for 2 seconds. The rate point jotted was at 0.6 seconds from the graph. The structure of the aluminum can be affected and may be anticipate a defect in which the aluminum casing could become weaker and more ductile due to heating. Even though the melting point of aluminum is 650 Celsius, from this observation, the rocket component should not be having any defects before and while taking off, as the ductility of the casing has its own role for safety, which to avoid any screws and bolts to be shredded when it's too ductile. Based on the figure shows the 6 locations probe for the temperature on the interior aluminum surface. The highest temperature at 181.8 Celsius is located at location 4 at the end section of the combustion chamber to the nozzle. This section could be the most ductile, which may cause defects and jeopardize the component. In the future, the research may be continued to find the strain rate and the structural integrity of the rocket component with elevated temperatures. Last but not least is the conclusion. It can be concluded that the present study shows the importance of undergoing thermal analysis on rocket components. Secondly, the highest temperature reached close to the outer surface of the aluminum casing within 0.6 seconds was 181.8 Celsius. Finally, the strain rate and temperature have a significant impact on the flow response and microstructural characteristics of 6061 T6 aluminum alloy. Thank you for paying attention to the presentation. If anyone had any queries, please do contact me through the following details. With that, Assalamualaikum warahmatullahi wabarakatuh. Thank you and have a great day.